Okay, so earlier we saw how to find out the order and degree of a differential equation. So now let's see how to form a differential equation. So whenever we form a differential equation, we should keep in mind that it should be free from the arbitrary constants. So what does it mean? So for example, you need to keep this in mind. Here, the order of differential equation is always equal to the number of arbitrary constant. So what is the arbitrary constant? For example, this is a equation. So this equation has one arbitrary constant. This is C. So if you want to get differential equation out of this equation, you need to differentiate this equation one time, because we have seen that the order of differential equation is equal to number of the arbitrary constant. So we will see how we will do it. So if you see the second equation here also, like, you will get only one constant. So you will be saying that here we have two constants, c1 and c2, but actually this all entire thing is a constant. That is c1 into e to the power c2 is a constant, for example k. So here only one constant again we are getting. So we will differentiate this only one time. Then in this case, if you see, so here also no. So here we get two constant. One is c1, another is c2x. So this is a different different term, and this is a different. So here we get two arbitrary constant. So we will differentiate it two times to get the differential equation. So just keep in mind that order of a differential equation is equal to the number of arbitrary constant. And if suppose there is three constant in a equation, then the order of that differential equation that you will form will also be 3, and you have to differentiate that equation 3 times, and you have to solve and get rid of the arbitrary constant in order to get the differential equation. So with example and illustration, you will understand this thing better. For example, let's see the first illustration. So this is a line equation, we know that. So here you can see two constant are there, two separate constant. One is m and one is c. So two constant are there, so order will be 2. As we saw here, that order of the differential equation is equal to the number of arbitrary constant. So if you see here, so you will differentiate it two times. So if you differentiate this equation once, then you will get this dy by dx is equal to m. And if you differentiate it again, so this m will become 0, and you will get the final differential equation. And you can check that here there is no constant, no arbitrary constant. So this is your final equation. So for a line equation which is y is equal to mx plus c, your differential equation is dy square by dx square equal to 0. But now let's see another example. So here another equation is there. So here we have to find the differential equation of this equation. So here if you see the constant, again we are having two constant, c1 and c2. So order of this differential equation will be 2. So you have to differentiate this equation two times and then solve the equation to get rid of the constant. So when you will first times differentiate this, so you will get dy by dx is equal to c1 e to the power x minus c2 e to the power minus x. Now differentiating it again, so you will get this double differentiation of y with respect to x. You get c1 into e to the power x, and here your minus will cancelled, and you will get plus c2 e to the power minus x. But this term you can see is having the constant c1 and c2, and you have to get rid of it. So here if you see, this whole term is equal to y from the parent equation. So just replace this whole term with y. So you get this final equation, that is double differentiation of y with respect to x is equal to y. So this is your final differential equation of this equation, which is there is no c1 and c2. So you finally got rid of the c1 and c2 arbitrary constant. So this is your differential equation. So you can see that in both case, here if you had two arbitrary constant, so your degree is also 2, and here also you had two arbitrary constants, so your degree of the differential equation is also 2 here. So now, no, sorry, by mistake I said degree. Actually the order is 2, and here also order is 2. We have seen that the number of arbitrary constant is equal to the order of the differential equation. So now we will solve one question, which is a very good question. So here you can see that you have two arbitrary constant, so you will have to form a second order differential equation. So you need to differentiate it twice. So when you will differentiate it for the first time, you will get 2y into dy by dx. So actually we are differentiating with respect to x on both sides, and this side you will get 4a, and this 2 if you cancel from both sides. So this is your first equation. Now you have to differentiate it one more time. So if you see, applying the product rule, so we are differentiating with respect to x only on both sides, and this will, like, if you see, you will get 0 in this side. So applying the product rule, so first you will differentiate this and taking this as constant, so this will give you dx by dx, and if you multiply this you will be getting a square over here, plus the second time this will be, y will be constant, and you have to differentiate the second term, that is this, and here RHS side you get 0. So this is the final differential equation that you get from this equation.